All right, let's dive into something truly fascinating today. We hear so much about large language models, LLMs, right?
Sure.
And how they're changing search, like Google or ChatGPT.
Yeah, it's all over the news.
But what if I told you there's this, huge area where they're having an even bigger impact on how you engage with stuff online, but it's way more under the radar?
Oh, you mean recommendation sisters?
Exactly. Recommendation systems.
It's actually incredible when you think about it. Take YouTube, for instance. Massive global app.
One of the biggest, yeah.
And the vast, vast majority of the time people spend watching videos there, it's driven directly by recommendations.
Right, like the homepage suggestion.
Homepage, the watch next videos that pop up, shorts now too, even how search results get personalized for you. So when you look at the sheer scale of consumer engagement affected, it's arguably a much larger playground for LLMs than searches.
That's a really interesting way to frame it. So our mission for this deep dive, then, is to unpack how YouTube is taking these super powerful LLMs, specifically Gemini, and basically rebuilding its giant recommendation engine.
Yeah, and they've come up with some really clever ways to, as they kind of put it, teach Gemini to speak YouTube.
Speak YouTube. I like that. Okay, so let's start at the beginning. The core problem with recommendations. What is it, fundamentally?
Well, at its heart, you can think of it like trying to learn a function, a really complex one.
Okay.
You take a user and all their context, who they are, what they're doing right now, that's the input.
Gotcha.
And the output. It's
Yeah.
supposed to be this perfectly curated list of recommendations, stuff they'll hopefully love.
Simple idea, but I imagine the context part is where it gets tricky. What kind of information does YouTube actually use?
Oh, a ton. It's not just the basics like, age, gender, location. They look at your context. What were the last, say, 100 videos you watched?
100. Wow.
Yeah, and how deeply did you watch them? Did you comment? Did you subscribe after watching? All that engagement data.
Right.
And, they've been working on this for years. There's a long history of different models. They've tried things like multi-headed rankers, sequence-to-sequence transformers, really sophisticated stuff even before LLMs became the big thing.
So they had all these advanced techniques already. What changed? Why the pivot?
Well, about 2 years back, they saw the just incredible progress happening with models like Gemini in understanding language and reasoning.
Okay.
And they started thinking, what if we adapt that for recommendations? This led them to create something called LRM,
LRM.
Large Recommender Model. Basically, they take a foundational Gemini model, a checkpoint, and then they infuse it with tons of YouTube-specific information.
So making it fluent in YouTube, like you said.
Exactly. It creates this unified YouTube-specific checkpoint.
And what do they do with that?
Then they fine-tune it. They align it for specific jobs within the recommendation pipeline, like retrieval, finding candidate videos, and ranking, ordering those videos.
Right.
And from that big LRM, they can create smaller custom versions for the different places you see recommendations, like the home page or watch next.
So is this, live now? Are we seeing this?
Yeah, LRM has actually been launched in production at YouTube for a while now, handling the retrieval part. They're still experimenting with it for the ranking side, but it's definitely out there.
Okay, so LRM is this Gemini model that understands YouTube.
Mm-hmm.
But hang on, LLMs work with text, right? They tokenize words. How do you tokenize a video? That seems like a massive hurdle.
That was the fundamental challenge. You hit it right on the head. Ideally, you want to feed video tokens in and get video tokens out for recommendations.
Video tokens.
Yeah, some way to represent the essence of a video as a token.
Yeah.
I needed this to compress the information. I mean, even if you have a huge context window, maybe 1 million tokens, you still can't just feed raw video data in.
Right, that would be insane.
And they tried other things first, like trying to predict search queries related to a video or trying to directly predict the next video ID, but they just weren't good enough, didn't capture the nuance.
So what was the breakthrough?
The breakthrough was something they call semantic ID, SID.
SID.
Think of it like this. They had to invent the basic building blocks, the sort of atomic units, for a whole new language of YouTube videos.
A new language. How does that work?
Okay, so you take a video, you pull out a whole bunch of features.
Like what?
The title, the description, the transcript if it has one, the audio signals, even data from specific video frames.
Okay, a lot of stuff.
All of that gets crunched down into what's called a multi-dimensional embedding, a rich mathematical representation.
Right, embeddings are common.
But then comes the clever part. They quantize it. They use a technique, RQVE is the technical term, but
Mm.
basically it compresses that rich embedding into a unique token or a sequence of tokens, a unique identifier for that specific video's meaning.
Ah, so each video gets its own word in this new language.
Pretty much. It's like they're creating the vocabulary for YouTube itself.
That's fascinating. So you could potentially organize billions of videos using these meaningful tokens.
Exactly, billions. And they're semantically meaningful. So imagine, like, the first part of the token might tell you if it's broadly about music or gaming or sports.
Okay.
Then within sports, the next part might specify which sport, say volleyball.
Right.
And then 2 different volleyball highlight videos might share all those initial token parts, that prefix, but then have a unique final identifier that distinguishes them.
So you're moving from just like random hash IDs to IDs that actually contain information about the video's content.
Precisely. It's a really interesting milestone, moving to semantically meaningful tokenization at that scale.
But what about new videos? Content gets uploaded constantly. How does a new video get a semantic ID, and how does the system know what it means?
That's one of the coolest parts. The training for SID is entirely unsupervised.
Unsupervised.
Meaning they don't explicitly tell it, this is a sports video or this is a movie trailer. The system just looks at all the features and learns these concepts implicitly by grouping similar videos together in that embedding space before quantization.
Wow.
And crucially, because it's learned these underlying concepts, when a new video comes in, it can be placed into the semantic space almost immediately. They call it a warm start.
Ah, so it doesn't start from zero.
Exactly. It dramatically improves how quickly they can start recommending brand new videos, stuff uploaded in the last day, even the last hour. Performance gets way better for fresh content.
That's critical for YouTube. And you mentioned video frames feeding into this SID.
Sure.
Are they just sampling frames constantly? That sounds computationally heavy.
Yeah, good question. No, they're smarter than that. Given the scale, they can't just sample at like 30 frames per second. Instead, they intelligently select frames from what the system identifies as key moments in the video.
Like highlights.
Yeah.
Or maybe where viewers engage most.
Exactly. Areas of high engagement, significant scene changes, stuff like that. It's a much more efficient way to capture the visual essence.
Okay, so they have SID, this language for videos. What's next? How do you get the main LLM, the LRM, to understand and use it?
Right. That's the next crucial step. They call it continued pre-training. This is where they teach LRM to be essentially bilingual.
Bilingual in English and
Yeah.
YouTube SID.
You got it. They need the model to understand both regular English and this new semantic ID language.
How do they teach it then?
There are 2 main training tasks they use. First, they explicitly link text and SID.
Okay.
So the model learns to connect English descriptions like titles, creator names, topics directly to the video semantic ID. You might, for instance, give the model a SID and ask, what's the title?
And it learns to output the actual type.
Exactly. Learns that association. That's step 1. Connect the languages.
Makes sense. What's step 2?
Step 2 is about understanding sequences of watches. They use YouTube's massive trove of engagement data, basically, the paths users take, which videos they watch one after another.
Billions of user journeys.
Billions. So they feed the model a sequence like, okay, a user watched video A, then B, then C, then D, but maybe they mask one of them, like C.
Hide one of the videos in the sequence.
Yeah. And the model's job is to predict the masked video based on the SIDs of the others. By doing this over and over, it learns the relationships between videos based purely on how users actually watch them.
Ah, so it learns what videos naturally go together in a user's session.
Precisely. It's learning video-to-video relationships through the lens of user behavior.
So the end result of all this, you get a model that can understand English and these video SIDs, and it knows how they relate.
Exactly. It can reason across both domains. They give this really cool example.
Yeah.
Imagine a user watched a tennis video, then an F1 racing video, then maybe a math tutorial, all represented by their SIDs.
Okay, diverse interests.
Then the system sees a 4th video, just its SID, which happens to be about, say, artificial intelligence. Because the model has learned these complex relationships, it can infer, just from the SIDs, that this AI video might be interesting to technology fans, connecting it perhaps loosely to the math video or other latent signals.
Without needing keywords like tech or AI in the prompt, just based on the SID in the user's history.
It's just the SIDs. It's reasoning about the concepts embedded in those tokens. It's pretty powerful stuff.
That is genuinely impressive. But does teaching it this new SID language ever cause problems? Like, could it get too good at SIDs and forget English?
That's actually a really astute point. It's a real balancing act.
Oh, really?
Yeah, they found that if you overtrain it too heavily on just the SID prediction tasks, the model can start to, well, forget to speak English, as they put it. Its general language capabilities can degrade.
So how do they manage that?
They're experimenting with different techniques. One promising approach is using a mixture of experts.
Mixture of experts.
Yeah, it's a way to structure the model so different parts specialize. Some parts might focus heavily on the SID relationships, while others explicitly work to retain strong text understanding and generation capabilities. It helps maintain that balance.
Interesting. Okay, so we had this powerful bilingual LRM. How is it actually being used? What's the first big application?
The first major application they rolled out is called generative retrieval.
Generative retrieval.
Okay, so for each user, in real time, they construct this really detailed, personalized prompt.
What goes into the prompt?
All sorts of things. Demographics, maybe a 24-year-old woman in the U.S. using an Android phone. Context, like the specific video she's watching right now.
Wow, okay.
And her watch history, maybe the SIDs of the last 50 videos she watched and how she engaged with them. All that goes into the prompt for LRM.
And what does LRM do with that giant prompt?
It then essentially dreams up or decodes a set of video recommendations, outputting them directly as SIDs.
So it's generating the recommendations as SID tokens.
Exactly. And the results are fascinating. It generates these really interesting, sometimes quite unique recommendations, especially for what they call the hardest recommendation tasks.
Hardest tasks, like what?
Like maybe finding relevant content for users they don't have a lot of history on, or finding connections others miss. They had this Olympics example.
Yeah.
Say you're watching a men's track final. A traditional system might just suggest more men's track races.
Makes sense.
But LRM, because it can connect your demographics, your broader watch history, and the context in a much deeper way, might actually surface a related women's race or maybe a profile of an athlete from your region. It finds these non-obvious connections.
That's where the real value is, right? That's serendipity. Discovering something you wouldn't have found otherwise.
Exactly. Especially for users where the system doesn't have much data, LRM can make much more informed guesses.
Okay, this sounds incredibly powerful.
Yeah.
But you mentioned it's based on Gemini. Those models are notoriously huge and expensive to run. How on earth does YouTube deploy this at their scale? That must be a nightmare.
Oh, it's a massive challenge. You're right. The model is powerful. It's efficient in terms of how much training data it needs. It handles the toughest tasks.
Right.
But it's really, really expensive to serve, to actually run it live for every user request. YouTube apparently had to find over 95% in cost savings just to make it feasible to launch.
95%, that's staggering. What makes it so much harder for YouTube than, say, running a standard LLM chatbot?
Several things are unique to YouTube's situation. First, just the sheer size of their vocabulary and content library.
Right, the SIDs.
Yeah. A typical LLM might have a vocabulary of maybe 100,000 word tokens. YouTube has, 20 billion videos represented by SIDs with millions more added every day. The scale is just different.
Okay, point one, vocabulary size. What else?
Second, freshness. This is way more critical for YouTube than for most LLM applications.
Also,
Think about it. If Taylor Swift drops a new music video.
you want to see it recommended immediately?
Exactly. Within minutes, or at least hours. If it takes days, users get frustrated. This means YouTube can't just train its big LRM model every few months like you might with a classic LLM. They need continuous pre-training, updating the model on the order of days and hours to keep up with new content and trends.
Days and hours versus months. That's a huge operational difference.
Massive. And the third big challenge is just the scale of serving itself. Gemini Pro, the big, powerful model, there's just no way you can serve that directly to billions of daily active users making requests constantly. The latency would be too high, the cost astronomical.
So they need smaller, faster versions.
Much smaller, much more efficient models, things perhaps more like the Flash variants optimized for speed and cost, just to meet the latency and throughput requirements for a service like YouTube.
Okay, huge challenges. Vocabulary, freshness, serving scale, and cost. You mentioned 95% cost savings.
Yeah.
How do they achieve that? Do they find a clever workaround?
They did find a really clever workaround, especially for the serving cost issue. They utilized something called an offline recommendations table.
Offline table. How does that work if recommendations need to be personalized in real time?
Well, they realized they could take the user-specific parts out of the prompt for certain scenarios. Instead of asking, what should this specific user watch next after video B, they can ask a more general question offline. If anyone is watching video A, what are generally good candidates to watch next?
So pre-calculating potential recommendations.
Exactly. They use the powerful LRM model offline to generate these high-quality candidate lists for potentially billions of videos, mapping video A to potential videos B, C, D, etc.
But wouldn't that lose the personalization? Usually unpersonalized recommendations aren't as good.
Normally, yes. But here's the trick. Because LRM is trained so deeply on user behavior and semantic understanding via SID, even its unpersonalized recommendations, video A, video B, are actually incredibly nuanced and differentiated compared to older methods.
I see. So the quality is still high, even without the specific user context in that moment.
Right. So they can do this massive computation offline, build this giant lookup table, and then when you're actually watching video A, the serving system can just do a super fast, cheap lookup in the table to get great candidates.
That's brilliant. Leverage the power of the big model offline. Then use a simple lookup for real-time serving.
It's a very smart way to get the best of both worlds, the intelligence of LRM, without the crushing real-time cost for every single request.
Okay, this has been incredible. So if someone listening wanted to apply these ideas, maybe not at YouTube scale, but the core concepts, what's the kind of LLM for recommendations recipe here? You said it's like 2 years of work condensed.
Yeah, we can boil it down to maybe 3 key steps
Yeah.
based on what YouTube figured out.
Okay, step 1.
Step 1, tokenize your content. Just like LLMs need text tokens, you need to figure out how to capture the essence of your content, whether it's videos, products, articles, whatever, into some kind of atomic token.
Just sutures to embedding to some kind of quantization or tokenization like SID.
Exactly. The goal is to create your own domain-specific language, the basic vocabulary for your content.
Got it. Tokenize. Step 2.
Step 2, adapt the LLM. Take a base LLM and teach it to be bilingual.
English and your new domain language.
Right. You need training tasks that link the two, like associating text descriptions with your new tokens. And you need tasks that help the LLM reason using those new tokens, like predicting the next item in a user sequence. The outcome is that bilingual LLM that understands both worlds.
Makes sense. Adapt the LLM. And step 3.
Step 3, prompt with user information. Construct those rich, personalized prompts using user demographics, their recent activity, their context. Use these prompts to train task-specific models, maybe smaller ones derived from your big bilingual LLM.
And that gives you the final system.
That gives you your generative recommendation system running on an LLM foundation tailored to your specific needs and services.
Tokenize, adapt, prompt. That's a great summary. So looking ahead, where does this all go? What's the future of LLMs and recommendations?
Well, right now, as we discussed, LLMs are mostly augmenting recommendations. They're boosting quality, finding better candidates, but it's often invisible to you as a user.
The underhyped part.
Exactly, which is why it's so underhyped. But the near future, stuff they're actively experimenting with now, is really exciting.
Yeah.
That bilingual LLM. It opens the door for you to actually talk to the recommendation system in natural language.
Like, tell it what I'm looking for.
Yeah, steer the recommendations based on your current goals. Show me something relaxing but not boring, or find cooking videos that use ingredients I already have.
Wow.
And critically, the recommender could start explaining its choices. I recommended this video because you recently watched these other 3, and it shares topic X.
Explainable AI for recommendations. That would be huge.
Huge! And notice how this starts to really blur the lines between traditional search and recommendation. It becomes more of a dialogue.
That makes total sense.
Okay.
That's the near future. What about further out? Any more provocative thoughts?
Well, if you really push the idea forward, recommendations and generative content might start to merge.
Merge? How?
Instead of just recommending an existing video or article, what if the system could recommend a slightly personalized version of it?
Tailored just for me.
Or maybe even start creating content on the fly to perfectly match your request. Imagine asking for a 5-minute summary of a specific historical event explained at a high school level, and it just generates it for you.
Ooh, that's the
Whoa.
end of one content, right?
Right.
Generated uniquely for a single user.
Exactly. That's the provocative thought. And honestly, with the pace of AI development, especially in generation,
Do you think it's closer than we imagine?
I think it's going to come sooner than you expect. It shifts from finding content to truly shaping it for the individual.
What a journey we've taken here. Seriously, from understanding just the sheer scale of YouTube's challenge to this idea of inventing a whole new language for videos with SID, and now seeing how this deep intelligence is working behind the scenes in our feeds. It's kind of mind-bending.
It really is. And it leads to a fascinating final thought for you, the listener, to chew on.
Okay, leave us with something to ponder.
If these recommendation systems, powered by LLMs, get sophisticated enough to explain why they suggest things, and maybe even start generating personalized content just for you,
Yeah.
how does that fundamentally change everything? How we discover information, how we consume media, maybe even how we create things ourselves? What kind of end-of-one experience, that perfectly tailored piece of content or information, might you dream of having in the very near future?